So, uh, good evening once again, guys. So, in the past few sessions, we were started over with the AutoCAD session, and especially we learned a lot of commands, especially studied about draw commands, modify commands, and similarly learned about the layer tools, block tools, and even at the end of the session, we learned about the annotation commands, isn't it? So I hope you have a little bit or a whatever like a furthermore knowledge in the AutoCAD command side. Now we are going to draft our machine side, which means the ducting related things. So let's get started. So this is the project that we've been already done. You know, the name is Mourya Project. So obviously, here initially we started over the heat load analysis step, isn't it? In the heat load analysis, we just found out the actual tonnage required for the machine that I need to install right here itself, isn't it? So regarding with the Excel sheets, you've been got some kind of tonnage value according to the CFM range. But in that study, we beg your pardon, on the Excel sheet, we got the tonnage around like 6.2 ton according to the DCFM value, isn't it? So the first thing here, just go on to the data. The client is advising you to take a ductable AC, and these ductable AC should be located near to this storage space. So this is the client requirement for the project right now itself. All right. So now I'm going to explain the certain factors that you need to consider while placing a mission. So we studied that inside a mission, you will be having uh, belt-driven fans, probably for high tonnages, or even like a direct transmission fans. It creates noise. So obviously, when these machines are placed on top of your working area or the other interacting area, you know, it should be a bit disturbance for the occupancy right there itself, isn't it? So for them, it's like a buzzing sound around their room itself. So that's why always these machines are advised to install where there is a less occupancy and a less human interaction area. All right. So this is the first step that you need to consider while placing a machine. That's why here client already advised you to place the machine near to the storage space. Why? Because here there is no seatings and it's purely a non-occupancy area, which is meant to be in a less interacting area, isn't it? So that is the first point. Now let's start it, or we can just discuss about to choose the machine. So as per the heat load analysis, I got the tonnage around like 6.2 ton. So here I'm using Blue Star catalog or a Blue Star catalog in order to take out the mission spec. All right. Once again, guys, while drawing a mission right inside an AutoCAD is a very important thing. Why? Because then only the client will get a proper idea about what is the tonnage of that mission, and similarly where these missions should be placed. So these ideas can be only grasped by the client by placing the mission according to the data. So initially I told you this is a top view drawing. So in top view drawing, while drafting a mission will not provide you the height of the mission. Instead of that, it will simply provide the top view of the mission itself. So here, while choosing the mission and the other aspects, we must need to take accounts of the data, especially the indoor dimensions. So let's hop over to that topic itself. Here you can see I've been choosing air-cooled split air conditioners, R1, R2 series, isn't it? And these are the machine lineups provided by Blue Star Air Conditioning. So R1 and R2, I already explained you that R1, which means they will be using R22 refrigerant, R2 compressors, which means they will be using R407C or 410A refrigerant. So it simply means the 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 compressor type. That's what this R1 and R2 meant to be. All right. So let's choose the machine that I will be requiring for the project right now. Here, in this case, the actual tonnage that we got is around like 6.2 ton. So considerably, if you check onto this machine lineups, we can't catch anything don't has to be like 6.2 exact machine. So these are the standard lineups provided by the company itself, which means the first machine that you can purchase is from 3 ton, and the next one is 5.5 ton, and similarly 8.5 ton, 8.75 ton, and there are two different 11 tons are there. It's according to the capacity control. You can see right here itself now. It's meant to be the capacity control of this two machines. Okay, then the thing that we need here is about the choosing of machine. So 6.210, which means I can't choose 5.5, isn't it? Why? Because it should be less sized. So the only option that I need to go, it's with 8.5 ton itself. All right. So 8.5 ton is the actual machine that I will be requiring for the project according to your company aspect. I told you guys, actually, this I'm considering according to Blue Star. If you're working for Daikin, the Daikins will be having a certain ductable lineups. So just go on and take those values. Once you finalize this mission, then the next thing that you need to check it is the nominal airflow. Here, they provided the value both in CFM and CMH. So CFM means to be what? Cubic meter per hour, isn't it? What is sorry, CMH, which means cubic meter per hour, and CFM, which means cubic feet per minute. So, however, always the CMH value should be greater than that of CFM. You can see the actual CFM required for 8.5 ton mission is around like 3,400, whereas the CMH value is 5,780 CMH itself. So this is the concept between these two. Then if you need to convert the value from CMH to CMH, just multiply this value with 0.589. Okay. That means 5780 into 0.589 will give you around like 3,400 CFM. So after getting these both data, next important thing is the indoor dimensions. You can see the indoor dimensions. So for respective of this 8.5 ton mission, the indoor dimensions are provided as to be 1500 mm width and 635 depth, and the height of that machine should be 460. So in this scenario, we can't uh, symbolize or exponentially provide the height of the machine. Why? Because it's a top view drawing. So the sole thing that I will be requiring right here itself, it is the width and depth. Once again, we studied that this project is actually in units, isn't it? You check onto this UN, you can see it is mentioned in architectural inches. So obviously this is an inches drawing, but here the value is in millimeters. So you must need to convert the value into inches and you need to draw that machine. Clear? So this is the first step of finalizing the machine according to the company spec and according to the heat load outputs. All right, guys. So I hope it's clear. Next of all, it's about the drafting of mission. Okay. So the first step is the choosing of mission and finalizing the mission according to the heat load uh, outputs, especially the DCFM value. And you need to check whether the mission is available or not. All right. And later, now I'm going to draft the mission. So what is the dimensions of that machine? That is 1500 mm cross. So I'm going to just mention it right here itself. The machine dimensions is 1500 cross 635, isn't it? So this is the dimensions for this one itself. All right. So I think you can see right here itself. Now, I need to draft a mission. So yesterday, I told you that whenever you are trying to draw onto an architectural drawing, you must need to include some kind of layers. So especially here also, initially I'm going to turn off the unwanted things right inside my project, like this text and other data. Now it's feel free to draw, isn't it? Now let's start it about to create layers. Once again, you know the command which is LA, layer, and create a new layer. Okay, create a new layer called as to be AC equipment. What is it? AC equipment. Then the color of this AC equipment layer should be normally blue. And once again, you need to create something called as to be AC trapdoor. So you know the purpose of trapdoor. It is used to access the machine from the false ceiling itself without breaking the entire false ceiling area, isn't it? That's why we are using trapdoors. So for here, the trapdoor color is generally 8, which supposed to mean to be some kind of gray color. Then the line type is not continuous. You need to load it down, which has to be ISO dash. That's it. So the first, it's not mandatory though, but I'm still saying, guys, the layer creation is very important. The name is optional, and you know, after that, set it down into the ISO dash and click OK. Your line type is updated right here itself. Once it's done, just click onto the AC equipment and make it as to be the current layer. That means set current option. That's it. Close the close the layer down, and now we can ready to draw the uh, machine. So as I told you guys, this is a top view drawing. So the machine should looks like a rectangle, especially for this dimension, isn't it? Before going into that thing itself, I'm gonna convert the value into inches. So 1 inch equal to 25 mm. So 1500 divided by 25, which is 60 inches, and 635 divided by 25, which means it's around like 25 inches. Okay, now we got the dimensions has to be 16, 60 cross 25, isn't it? With the help of this rectangle command, drag a rectangle, use the dimension command, and after that, 60-inch length and 25-inch width. Okay, that's it. Now your rectangle is ready. This is meant to be the machine, and I told you guys this is a top view drawing, so that's why it is mentioned like this way. Now you need to enter some kind of data. So if you having something called as to be AC text, you can use that. For that one, I'm gonna use something named as to be AC text. Okay, what is it? AC text. That means the texting for this air can the HVAC side. You get a green color and set color. That's it. So it's for general purpose. I'm using an AC equipment itself. Now multi with the help of this multi-text command, drag a option like this itself, and you can name the mission such as to be 8.510 DSA IDU, and what is the CFM? 3400 CFM, and either you can enter the dimensions in millimeter or inches. So here I'm purely entering in millimeter itself, 635 into then 460. All right. So once you enter this one, I told you now, actually we can edit this options as to be like, which means, oh my gosh, I am changing it as to be Romans. Then I'm gonna color it, change the color as to be green color, and you can even edit this options as to be 3 inches thickness. All right. Now our machine is sorry, the machine data is ready right now itself, isn't it? Later, it's about the trapdoor creation. So why we need sorry, the general concept of trapdoor is very simple. You need to provide a 1 feet distance from each and every corners, or 1.5 feet distance. Here I'm providing a 1 feet offset. So I'm going to use offset 1 feet. Now you got something like this, isn't it? Once you got this option, just select the second rectangle, which is offsetted from this one, and swap it down to AC trapdoor. You can see now the AC trapdoor is ready right now itself. And once again, you need to provide some kind of extensions like this way. Sorry, with the help of line command, you can extend to the other ends And with the help of trim command, we can actually delete this ones. Okay, now once it's ready, we can select the other two lines and delete it. Now your uh, machine with trapdoor is ready. So the concept is very simple, guys. This trapdoor is below the machine itself. Okay, that's why I shown this one. Later, it's about the mouth size connections. So again, I'm swapping this one into AC equipment itself. What? So whatever, here, each and every machine is having a mouthpiece connection. So in the machine study, I explained you that it has to be the mouth sizes or the mouthpiece connections are depends upon the tonnage itself. As in the case of Blue Star, till 1110, it should be a single mouthpiece machine. So here also, I'm going to consider it as to be a single mouthpiece machine itself. Then these mouthpieces also have some kind of dimensions, such as to be 20-inch and even 18 inches. So here I'm going to use 950 mm width and 350 mm height. That's how an mouthpiece should looks like, isn't it? So I will show the picture of this one. It is around like 38 inches, isn't it? Is it nice? 38 inches. I hope the thing you forgot the mouthpieces also, isn't it? Or did you forget that one? Yeah, this is the mouthpiece. Okay. So these mouthpieces, this is a dual mouthpiece machine, and this is a single mouthpiece machine. So this for single mouthpiece also, they having defined dimensions of it. So that's dimension is around like 950. Once again, guys, it's only for 8.510. These values should be provided by right inside the company catalogs itself. Okay. So here the value is 950 mm, which I got from the catalog itself. Okay. So 950 mm is converted into inches. I got it has to be 38 inches. So initially, these mouthpieces are drawn in cyan color because it's a continuation of duct itself, isn't it? So that's why I'm gonna draw it down in cyan color. Then take the midpoint, okay? Take the midpoint, turn F8, okay? Turn the ortho mode using the F8 tool and just draw a random line like this itself. Now after that, what is the midpoint? Sorry, what is the half of 38, which is 19 inches, isn't it? So offset it down with 19 inches. Offset 19 inches on both sides like this way. Okay. So once you got this one, again, you with the help of a line command, you can draw the actual mouthpiece. Now you can see right here itself, guys. This is meant to be the actual mouthpiece, which is attached with the machine. Next, we studied the second fitting, which starts from the machine should be probably an FCC, which is a flexible canvas connection, isn't it? What is it? A flexible canvas connection. So how to size the flexible canvas connection? Normally, the length of the flexible canvas connection is around like 6 inches. Okay, so I'm going to offset this line specifically only for 1 inches and using the multiple command, you can see 1, 2, 3, 4, 5, 6, and 7. Okay, and once again, offset this also for 1 inches. Okay, now once you got this one, just delete this line with the help of this extend command. Click this has to be the reference. And after that, extend each lines alternatively like this. Okay, so that's it. So this line is not required though. Once it's done, with the help of a polyline command, just join these edges like this way. Is it clear now? Now delete this line off and select the polyline. So that's why I drawn not in line method, but in a plane method itself. Mirror it off by selecting this midpoint, and you can see no. Then you'll be getting the same structure on the other end also. Select this option, use the extend command, just extend it off to the other ends. That's it, guys. Now your machine is ready, included with your mouthpiece connection. All right. So this is the primary step. Initially draft the machine according to its dimensions, create the layers for them, and draw it off, means draft it on the respective tools. And at last, you need to enter the data and including with the mouthpiece connection. Once it's done, you need to simply select the entire machine and make it as to be a block. That means be enter. Now it's asking for some kind of block definition. I'm going to mention it has to be IDU and picking the point, not this one, always the machine base points. Then just click OK. Now your block is ready, isn't it? Then it's very simple to move on with whatever you need. Otherwise, you can simply delete it down. Why? Because it's already saved right inside your AutoCAD itself. So no need to worry about that stuff itself. So is the first step is clear? Clear
Can
as
you please block ഒന്നുകൂടി പറയാമോ?
block ആണോ? Okay,
Block
okay.
ആക്കിയത്. Block ആക്കിയത്.
Fine. Okay, okay. Sure, it's gone. Yeah. Okay. So it's very simple though. Yeah. So once it's done, select the objects that you need to make it has to be an entirety. And after that, use the command B, which is block command. Then a pop-up will open like this itself. And you need to specify the name, which is meant to be the respective name that you've been created. So obviously this is an indoor unit, isn't it? That's why I named as to be IDU. And you need to select this option called as to be pick point, which is the insertion base point. And I'm selecting this has to be my base point, not this one. So I will explain the perspective of selecting this point. Okay, later. Select this option. And after that, click OK. Then here I told you it's already created. That's why it is asking to redefine. So I'm gonna redefine itself. Once it's ready, it should be saved as to be a single block right here itself. Is it clear though?
Yes, clear.
Okay, fine. All right. The next step is to analyze the actual number of diffusers. So this is the important step in drafting of ducting. Why? Because here now we'll be going to discuss about the number of diffusers required for the project, and we need to find out the inner neck sizes, outer neck sizes according to the projects, and their placements are also important right here itself. So let's discuss about the sizes and the number of diffusers that I will be requiring for the project. For that one, I would like to show a simple calculation regarding with that things. So initially, in order to analyze the total number of diffusers required for the project, first one, the total CFM is, before that, generally, the recommended range of CFM in a per diffuser is around like 450 to 650 CFM. So generally 450 to 650 CFM is the recommended range of airflow right inside a diffuser. I'm not implying that it has to be, we can't provide greater than that of 650 or we can't provide 450, sorry, below 450 right in the diffuser. I'm just saying or simply stating it has to be, this is the recommended range. If you provide this much, it should be efficient and reliable for that one itself. Okay, so that is the concept of this point. Now let's discuss about the total CFM of that project. It is 3,400 CFM, isn't it? Then once you got this value, now the step is very clear: 3,400 CFM divided by per diffuser CFM. So the per diffuser CFM is ranged in between 450 to 650, isn't it? So if I'm supposing using it has to be 3,400 divided by 600, you'll be getting a value something like, how much you'll be getting here? I want to use that. 3,400 divided by. So guys, what did I got this 600? It is the in between range of this 450 to 650. That's why took 600 right here itself. 5.66, isn't it? What is the value? 5.66, which is nearly equivalent to 6 supply diffusers. Okay, so here in this project, I will be requiring 6 diffusers. So now I got the total number of diffuser. Once again, I need to know that how I'm going to split this CFM inside the each 6 diffusers, or what is the probable flow in a single diffuser. That is 3400 divided by 6, which is equal to 566.6, which is around like 566 CFM, isn't it? So this is the per diffuser CFM for this project. Am I clear with this point, guys? Clear? So is the step is clear? Tell me, guys. It's very important step. That's what I'm asking, repeating. Repeatedly, I'm asking. தமிழ்ல சொல்லணுமா? ஓகே. ஸோ நார்மலா நீங்க ஒரு டிஃப்யூசர் எடுக்கிறீங்கன்னா அதுக்கு 450ல இருந்து 650 சிஎஃப்எம் ஏர் குவாண்டிட்டி கொடுக்கலாம். இது ஒரு ரெக்கமெண்டட் ரேஞ்ச். ஸோ ரெக்கமெண்டட் ரேஞ்சுன்னு சொல்றது கண்டிப்பா கொடுக்கணும்னு சொல்ல வரல. இப்படி கொடுத்தா இல்லைன்னா இந்த அளவுக்கு கொடுத்தா அங்க ஓகேவா இருக்கும், எஃபிஷியண்டா இருக்கும்னு சொல்ல வராங்க. இதுக்கு கம்மியும் கொடுக்கலாம், அதிகமாகவும் கொடுக்கலாம். பட் ஹியர் நான் என்ன பண்றேன்னா சிம்பிளி இந்த ஒரு ரேஞ்சை வச்சு தான் கன்சிடரேஷனே எடுக்க போறேன். அப்போ மொத்தம் 3400 சிஎஃப்எம் என்னுடைய மிஷினுடைய மவுத்ல இருந்து வெளியே வருது. அப்போ இதை நான் ஈவனா ஸ்பிளிட் பண்ணி பிரிக்கும் போது எனக்கு எவ்வளவு டிஃப்யூசர் வரணும்னு நான் கண்டுபிடிக்கணும். ஸோ அந்த டிஃப்யூசர் குவான்டிட்டி தான் எனக்கு கிடைச்சது எவ்வளவு, யூனோ டிவைடிங் 3400 வித் 600. இந்த 600 நான் எங்க இருந்து எடுத்தேன்னா இந்த இன்பிட்வீன் ரேஞ்சில், ஓகேங்களா, இந்த 450 டு 650ன்னு சொல்ற இந்த ரேஞ்சில இருந்து தான் நான் அதை பிக் பண்றேன். ஸோ ஐ வில் பி கெட்டிங் அரௌண்ட் லைக் 6 diffusers. ஆல் ரைட். ஒன்ஸ் இந்த ஆறு நம்பர் ஆக்சுவலி இஃப் யூ ரிடக்ட் த வேல்யூ, இப்போ நீங்க 450 போட்டு பண்ணீங்கன்னா 6ன்னு வராது, அதுக்கு பதிலா 8ஓ 9ஓ கிட்ட வரும். ஸோ தட்ஸ் ஐ சூஸ் இட் ஹாஸ் டு பி 600. ஓகேங்களா? இனி ஒரு டிஃப்யூசர்ல நம்ம இங்க எவ்வளவு கொடுக்கணும்னு கண்டுபிடிக்கணும்ல, அதுக்காக தான் 3400 சிஎஃப்எம் 6 டிஃப்யூசரை வச்சு ஸ்பிளிட் பண்ணும்போது நமக்கு கிடைக்கிற வேல்யூ 566 சிஎஃப்எம். அதாவது இந்த 6 டிஃப்யூசர்லையும் நீங்க ஒரு டிஃப்யூசருக்கு எவ்வளவு கொடுக்கணுமா, 566 சிஎஃப்எம் நீங்க ப்ரொவைட் பண்ணணுமா. ஸோ இஸ் இட் கிளியர்? ஹலோ, ஓகே தானே? ஓகே. ബാക്കിയുള്ളവർക്ക് മനസ്സിലായോ? ലൈക്ക് അവിനാഷ് ആൻഡ് റൂസ് മാം, ഇസ് ഇറ്റ് ക്ലിയർ?
Yes, clear, clear.
Okay, fine, good, good. Okay, guys. So now we got the data of the diffuser that I need for this project right now itself. So once again, guys, the 6 diffuser means 6 supply diffuser. Okay, that is not the entire diffuser. I told you for each number of diffusers, I will be requiring a return diffuser also. So the ratio is like this way: 60% return and 40% supply. Okay, so this is the concept behind supply and return. Okay, then I told you in the beginning session itself, always the area of the return side should be greater than that of the supply side. That's why. Okay. So simply in here, I need to literally provide 6 supply and minimum 8 return. Okay, so this is the concept. So or less than or is equal to 6. That's what we will be requiring the return and diffuser quantity right here itself. All right. So that's it, guys. So once you got this value, now let's discuss about the inner neck data and outer neck sizes. I told you guys, generally the outer neck sizes that we can take, it has to be 2 cross 2, which is 24 cross 24, isn't it? Which is 24 cross 24. It simply means what? 24 inches into 24 inches. It is the grid ceiling. I told you that day itself now. So this value is very viable and directly taken from the existing conditions itself. But what about the inner neck sizes?
Hello.
Okay, so what about the inner neck sizes? Here, in order to find out the inner neck sizes, you need to find out the simple 3 datas, such as to be the CFM, which is around like 566 CFM. And it's about the velocity. So this is the point, guys, or this is the thing that I need to know. Okay, so now I just find out the CFM and this kind of stuff. For that one, now I'm gonna open something called as to be McQuay duct sizer. What is it? McQuay Duct Sizer. Actually, this is a software from McQuay specifically provided to design the duct sizing. Here you can see the air specification. Make it has to be 75-degree Fahrenheit air at 50% RH at 1 atm, which is the exact room conditions that we will be facing in each project, isn't it? Later, you can see the flow rates, head losses, the velocity, and the equivalent diameter and the duct sizes. It's all been mentioned right here itself, isn't it? So let's get started. I told you guys while sizing the inner neck sizes, we need to go with velocity reduction method. So at this instance, just enable onto the flow rate and enable this velocity. Okay. We are not preferring head loss method right now itself. I'm going to simple-handedly going with the velocity reduction method itself. So after this step, you can see these flow rates column is blank, isn't it? So enter the flow rate. What is the minimum flow rate for a single diffuser, which is around like 566 CFM, isn't it? Enter the value. And after that, provide the velocity. So what is the probable velocity? So this is the point, guys. I told you that, or we already learned it has to be the actual velocities right inside a collar duct, dropper duct, inner neck sizes. It should be across like from 450 to 650 FPM, isn't it? So initially start with the greater velocity, that is 650 FPM. Let's check on to the head loss value. It's still less than that of 0.1 inch of water column. So this one is acceptable. But it's not the finalization step. We might need to check with the available inner neck sizes. We studied that the available inner neck sizes values range between 6 cross 6, 9 cross 9, 12 cross 12, 15 cross 15, something like that, isn't it? So here also, I'm going to use the duct sizing as to be initially start with 6 cross 6. So if I enter 6, the output value also should be in 6, then only it is acceptable. Here you can see it is 25. That means 6 is not the value. Next, check with 9. What is the value we got? 15. That means 9 is not the answer for this. Let's check with 12. So here the value is, however, merging across this 11 itself. That means if we reduce the velocity, probably this value can be equal. So let's check it though. So I'm gonna, once again, guys, if you're having doubts on 15 cross 15, you can type the value. You can see the same value, 9. Okay, so that I told you this is our interloaded. That's it. Now I'm going to reduce the velocity. So that's why this step is called as to be velocity reduction method. Now I'm going to set the velocity as to be 600 and again do the same step. 6, that's 28. Let's check for 9. It's like 17. Let's check for 12. Now you can see the both values are, which means the input and output is same. That means we need a square diffuser, isn't it? So this means at 600 FPM, we can take the inner neck sizes as to be 12 cross 12. Okay. So we got the final answer for your inner neck sizes, which is 600 FPM, and the inner neck size is 12 cross, okay, 12 inch cross 12 inches. So is it clear? So is the step is clear? All right. So this is the diffuser calculation by, one second, please. Okay. So this is a step we will be importantly doing for each and every project. So this step is a mandatory one. If you not pretended to do this kind of steps, the entire project is waste. This step will give you the exact idea of duct routing and the placing of ducts across your area. That means simply the duct distribution. Now let's draft this diffusers. Okay. Now just we are going to draft this diffuser. For that one, I'm gonna create a new layer called as to the air terminal. What is it? air terminals. So the color is not important though. Why? Because however I'm going to change the color. Initially, I'm gonna start with magenta color and using the rectangle command. What is the outer neck sizes, guys? It is 2 cross 2, isn't it? So it is 2 cross 2. So dimension enter 24 inches and 24 inches. Now the outer neck size is ready. Then for the exact designing purposes or this drafting purpose, I'm gonna offset this diffuser has to be 1 inches. What is it? 1 inches or 2 inches. 2 inches should looks like neat and clean. So offset 2 inches and enter the value 2 inches. Not for the outside, but for the inside. Okay. If you make it has to be outside, what will happen? The value should be jump over to 26. That's the problem. Then M enter, which is multiple enter. Then click multiple times until it's getting a red. That means this is the last point. That's it. Okay. Now the diffuser outspec is ready now. Let's show the arrow marks, which means where the airflow is getting gone. Okay, for that one, I'm gonna change the color as to be. Before that, I'm going to take a simple copy of this one. It's for the return purpose. Okay, so this one for the return diffuser. Okay, one for supply and one for return. I'm gonna change the color of the return as to be red color. Okay, now that's it. Now I'm gonna use yellow color for the arrow purpose. So how to draw the arrows? Very simple. Pick the midpoint of this line and use the command called width enter. So here I'm starting with a width of 2 inches and 2 inches. Now you can see something origined like this. Extend it to a certain distance and click it off. And again, you need to type the same command called as to be width enter, and after that use the same width, but now this is meant to be the tail of an arrow. That means it should be probably greater than that of this base itself, isn't it? So here I'm mentioning it has to be 5 inches and the ending width is 0. You will be getting something like this itself, isn't it? Sorry, 4 should be enough. Yeah, the 4 inches should be enough for this. So that's it, guys. Your arrow is ready. Once the arrow is ready, the next step, select the arrow and make an array, especially polar array. Okay, make an array of polar array. Select this midpoint and I which means I enter, that is items enter, 4 number of items. Okay, that's it. Your arrow mark is ready. Once again, select this arrow. Now you can see it is a single array object, isn't it? Break it down with the help of explode command. Okay, break it down with the help of explode command. And after that, select this option, copy this one, and pick this arrowhead and directly paste onto the other end. That's why I linearly pasted it. Okay, you can see the relevance or importance of this copy pasting in this method. Okay, once it's done, again do the same thing, guys, which is a array, polar array. Select the midpoint, then items enter 4 number of items. That's it. Now your supply and return diffusers are ready. Later, I'm gonna select the magenta color. It's like not for magenta, it's for red. Here I'm going to mention this one has to be like a single-handedly. A line can be extended like this. That means no ducting is going like this. That's it. That symbolically means a small uh, connection is going only to the plenum area itself. So we forgot that actually we need to block it down, isn't it? So how to block it down? Again, select this option, type the command called enter, and after that SAD, supply air diffuser, pick the point and take it on the base point right here itself and click OK. Then once again, select this one and make it has to be RAD. Sorry, beg your pardon. Again, block command and RAD, which is a return air diffuser. And pick this point. Select this has to be the base point and click OK. Your both supply and return diffusers are ready. Once again, guys, we forgot to include our inner neck sizes, isn't it? So how to mention the inner neck sizes? Just double tap onto this block itself, like this way. So something called as to the edit block definition. Get onto the SAT and click OK. Now you can see something like this, isn't it? Turn off the F7. Okay. Turn off the F7. The grid should be turned off. Now it's time for the drawing. So here, in order to draw this stuff, actually you need to use something called as to be. The color should be in cyan color. Why? Because the duct color also should be cyan color. That's why. Draw it down. What is the dimension of the inner neck size? You already found it has to be 12 cross 12, isn't it? So draw this option like this itself and draw in another line like this way from this end to this end. And once again, this end to this end. That's it. And selected this option. Copy this one. Copy from this point to this point. Your inner neck is also ready. If you need much more saturation onto this inner neck sizes, like in order to denote something, you can use the command called pedit and W enter. I'm going to mention it has to be 0.15. So you can see the width of the line is increased, isn't it? That's it. Close it down. While closing the block editor, save it. So these things should be saved right here itself. All right. So this is the second step, drafting of uh, diffusers according to the design aspects. It is meant to be the calculation, guys. Okay, now. So is the designing is clear? Okay. Hello. Clear?
Clear, sir.
Okay. Fine. So once it's done, the next step is placing the diffusers. What is it? Placing the diffuser. So today, uh, in order to place this machine, you need to create some kind of grid ceiling for this. Then only you can properly uh, paste right here itself. So for that one, I'm going to use a certain command called as to be, sorry, a certain layer for this option. So here the naming it has to be AC grid. Create a layer, something like this itself. Grid ceiling. Okay. And here I'm initially starting with something called as to be the polyline. You know the polyline command, isn't it? So start over with the same thing that you've been already done, isn't it? Start from here, turn off the F8. It should be still helpful. The same thing that we've been used to take out the area. Remember? Then arc enter, D enter. That's it. Drag it down according to your need. This is a so you don't need to worry about the exact picking of points. It's just for the grid ceiling aspect. Okay. So don't need to worry about this stuff. Simply enclose the area with this line. After that, swap back again to line option, which is then the same line command. All right. So that's it. So now it's simple to create the grid ceiling for this project. Turn on F8. Okay, that's it. Now your polyline is ready, isn't it? Just select the polyline and move it off from the base like this way. And after that, now we are going to create some kind of grids. For that one, I'm going to use line command and just drag a line like this way with a different color. Okay, now offset of 2 feet, offset of 2 feet distance and M enter. Automatically you need to click this down right like this way. Once it's done, just escape. Do the same thing for here also. Then offset. Okay, now it's ready, guys. Now select the polyline and use the command called trim. Now we can see these things can be trimmed off like this way. Okay. Okay. All right. Now just delete the unwanted lines and select this grid as to be an entirety and make it as to be a single block. Okay. B enter. Name this one option as to be grid and pick the point. Again, do the same stuff. So it's an optional thing. You can do it or not. Or if you're having this layer, it is much more easy to work on. Now it's very simple to select and move this grid, isn't it? Select this grid and place right here itself. Now let's discuss about the other factors. This step is very important, guys, which is turning off the unwanted layers. So here I'm turning off the DC text and the furnitures also. Okay, so this furniture pieces should be, let's keep them there itself. Whatever. Now I'm going to place these machine and diffusers right inside here itself. For that one, you need to create a next layer called as to be supply duct, SA duct. And the color of the SA duct is cyan color. Okay, click OK, set current and close this option. Now use the command called as to be I. I stands for insert. And if you provide the name IDU, automatically you can see the thing that is being drawn, isn't it? The client advised you that it has to be place the machine near to the storage space, isn't it? So that's why I placed this machine near to the storage space. Later, placing of diffuser. Normally, while placing a diffuser, we need to consider two different things. The first one should be the in-between distance of each diffusers. Normally, the value is around like 6 feet from each diffusers and 2 feet from the walls. Okay, so let's get started. Again, I'm using the same thing. I enter, insert SAD, supply a diffuser. So here you can see. Now you can see the importance of this one. That's how you can simply place the diffuser right inside the grids. Okay, now. So the first one I'm placing is a supply diffuser. Then the in-between distance should be 6 feet. That means 3 tiles, isn't it? So while doing this much, this kind of things, the first things, lock the layers that you need. You don't need to select it, which is the furniture pieces and also the grid, isn't it? Now it's easy to draw and easy to place these things here, isn't it? Like insert RAD, return a diffuser. Oh my gosh. Yeah, click OK. Then place this one right here itself. So in now you can see the in between is 3 tiles, which is meant to be 6 feet, isn't it? Now select this one and this one, copy this one like this way. And after that, click this option. Sorry, beg your pardon, or like this way, copy this one and place this point or pick this point and do the same thing. Now you can see now it's 6 feet in between distance, isn't it? But for the top side, you need to change the pattern like this way. Then you can see right here itself now, like 3 feet right from here itself. You can see now this side should be supply and this should be return. For him, it's like return and supply. So this is how you need to swap your diffusers like this way. But while placing this diffuser, this is the way much more harder job for us. Why? Because while placing these diffusers, you must have an idea whether I can run a duct with a minimum number of fittings. And is it possible to connect with the duct? Is we have enough space to connect the diffuser along with the duct? So these much factors that we need to consider while placing a diffuser. Okay, so now I'm not going to place this one exactly according to the view. Tomorrow I will show the outputted views. Okay, so till now you guys need to draw this drafting today itself, then only the touch will be there. Otherwise, you will be probably forgotten this one. So that's why, so do this project until this placing of diffusers. So you can see right here itself, guys, if I take in a duct, can I connect this duct into the diffuser? So these things must be included and considered while placing this diffusers. Once again, each and every table is getting proper air conditioning. That means the supply should be placed across the occupancy sites itself. So that also is a factor. Clear, guys? Hello? Is it clear? Now that's it, guys. Now I would like to explain the other few factors regarding the finalizing of duct height. So how to finalize the duct height for your project? Let's discuss about that factor. Here, they given the BOS is 10.5 feet and the BOFC is 8 feet, isn't it? For example, I'm going to show with a simple rectangle. So this is the BOS value. And this is the beam goes like this way, isn't it? Now, here you can see the total distance is around like 10.5, isn't it? This one is around like, this one is around like 10.5 feet, which is the BOFC value, isn't it? But here you can see, and the BOFC value is 8 feet, isn't it? So that means 8 feet minus 10.5, which is around like 1.5 feet. So 1.5 feet is the, beg your pardon, not 1.5 feet. It's like 2.5, isn't it? Yeah, 2.5 feet is the total plenum area, or the available plenum area is 2.5 feet. But the problem is not this one. It is actually the BOB, which is the bot beam. So in this project, we having a beam. That means we can't consider the duct height has to be to the entirety. That means 2.5 feet height can't be considered. Instead of that, whenever if you encountered with this beam constraints, just consider beam and BOFC. So the beam value is 9.5 and the BOFC value is 8. Now the available area in between the beam and fall ceiling is 18 inches. That is 1.5 feet, isn't it? So can I consider 18 inches as to be the direct height of the duct? So you know the idea, isn't it? Why I'm saying is, gradually for cable trays and firefighting pipelines will be going, isn't it? Then for us, our, the HVAC ductworks are much more complexity, and the rigidity of these ducts are comparatively obvious while compared with the other coordinations like cable trays and firefighting pipelines. It can be neglected while when you encountered with a beam. But for us, if you having this beam, each time I can't use a offset piece like this way, isn't it? So that's why here we need to consider the in-between distance from BOB to BOFC, which is around like 18 inches. That is the available space in between the fall ceiling and beam. The total available plenum area is 2.5 feet. But which I mentioned before, here the problem is the beam. So whenever you got encountered with the beam, you need to consider the in-between distance from beam to fall ceiling. That you got it around like 18 inches. Now, let's discuss about the height finalization. That's very simple, guys. In order to find out the height, you need to start with the other aspects, such as to be insulation. So if they will provide with some kind of insulation, obviously, we need some clearance spaces. So if you take 1 inch clearance on the both ends, like here and here, it should be a much more lesser distance. Then the duct height will become 16 inches. But 16 inches, that means, 1 inch is not enough for us, isn't it? That's why we can conveniently give some more extra clearances. That means now the duct should looks like this. That means the height of the duct should looks like this by providing 2-inch offset on both ends. So here also 2 inches offset and here also 2-inch offset. The total should be now 14 inches. Okay. Still you can reduce the height like 12 inches, 10 inches. But tomorrow I will explain till where you need to redact the main duct value. Normally you can constrain up to 12 inches. All right. So this is how you may be considered your duct height for your projects. And once again, once you finalized your duct height values, you must need to discuss with your project management consultancy, and similarly with other coordinations. Okay, then once it's okay and they provide the approval, you can go with the same duct height value itself. So today we learned a lot of things. So is the duct height consideration is clear? It's purely the providing a proper clearance lengths in between those areas itself. Okay. Okay, guys. Fine. So is it clear? So tomorrow you must need to place these diffusers according to the seatings with a minimum number of fittings consideration. Okay, so tomorrow I will explain about that working. Just try to place these diffusers across your workspace. Okay, now. So till now, we learned a lot of stuff. Started with the equipment creation, drafting of equipment, and similarly designing of the diffuser inner neck size calculations. And we also drafted the inner neck sizes and diffusers even for the project separately, like supply and return. And I told you the maximum number of diffusers, it should be probably the return itself, not the supply. Okay, so you must need to place the diffuser wisely for the project itself. And we learned about the duct heighting calculation also, isn't it? So I think it's enough for today. Tomorrow we will catch up with the remaining topic itself. Okay, so is it clear?
Sorry, doubt.
Yeah, go on.
നമ്മളിപ്പോ ഈ ക്ലീൻ ഏരിയയുടെ അവൈലബിൾ ആയിട്ടുള്ള സ്പേസ് നോക്കിയിരിക്കും
Hmm.
ഹൈറ്റ്.
അതെ.
അപ്പൊ അതില് ഫോൾ സീലിംഗിന്റെ തിക്നെസ് അതിന് ബാധകവും.
ഫാൾ സീലിംഗ് ശരിക്കും പറഞ്ഞാൽ ഫാൾ സീലിംഗ് തിക്നെസ് ഒന്നും ആവശ്യമില്ല. കാരണം ബോട്ടം ഓഫ് ഫാൾ സീലിംഗ് എന്ന് പറയുമ്പോൾ ഫാൾ സീലിംഗ് നോർമലി 1 ഇഞ്ച് 2 ഇഞ്ച് അങ്ങനെയൊക്കെ പോത്തുള്ളൂ. അതാ പറഞ്ഞ അതിനും that's I told you guys, you need to properly take out the clearances according to the condition right there itself. എന്നല്ല പറഞ്ഞേ, മനസ്സിലായോ? ക്ലിയർ ആണോ അവിനാശ്? അത് നമ്മൾ എടുക്കണ്ടേ? ഇപ്പൊ ഗ്രിഡ് ആയിരിക്കാം, ചിലപ്പം ജിപ്സം ബോർഡ് ആയിരിക്കാം, അല്ലെങ്കിൽ നമ്മുടെ നോർമൽ ചിലപ്പം വെറുതെ ഇട്ടിട്ടുണ്ടാവും, എങ്ങനെയാണ് ഉണ്ടാവും, മനസ്സിലായോ? സോ ഇറ്റ്സ് അപ് ടു ദ സൈറ്റ് കണ്ടീഷൻസ് ഇറ്റ്സെൽഫ്. All right. So that's itself, guys. Today I will share this video and go through this video once again, guys. Then we can catch up the remaining session. So I told you one homework will be there, which is to place the diffusers according to the uh, area. Okay, now that's it. So we can wind up our session. So okay, guys, have a great day. Bye.